Good morning, everybody, and thank you for joining us for our webinar on using the Spatial Business Systems plugin for FME to access GE Smallworld data. With us today, we've got Andy Street, who's the VP of Technology at Spatial Business Systems. Hi, Andy.
Hello there, Mark. How are you doing? Hello, everybody out there.
And myself, Mark Stokes. I'm the Manager of Support here at Safe Software, and I'm just going to take a back seat today and let Andy do the bulk of the presentations. Spatial Business Systems has been a Safe Software reseller and partner for a long time. Since 2003, we work very closely together. SpatialBiz are a full services organization, and they provide geospatial technologies to utilities, telecommunication, government markets. And they work in a wide variety of GIS platforms. They're a GIS independent group, have a lot of experience in Smallworld and Oracle Spatial, as well as Autodesk and Esri products, along with the usual Google Maps and Intergraph and IBM tools. They've got offices in Lakewood, Colorado, just outside Denver, and also an office in Melbourne, Australia. And Safe Software ourselves, we're here in Vancouver, actually in Metro Vancouver, the city of Surrey, and there's about 100 of us here in that Vancouver office. Today we're going to spend about 60 minutes looking at how the Spatial Business Systems plugin for FME can help you work through some Smallworld imports and extracts. Andy is going to give us some demonstrations on reading data from Smallworld, dynamically reading data from Smallworld through Esri tools, writing data into Smallworld, particularly structuring complex features and multiple geometry features. And then one of the great things about the SpatialBiz plugin is that it opens up the use of our secondary product, FME Server, and so that can be used with Smallworld. And then Spatial Business Systems have put together some very interesting tools on synchronizing Smallworld with Oracle Spatial. Andy is a non-PowerPoint user, so basically all of his presentation is going to be through live demos and not a set of PowerPoint slides, which is great. In terms of the webinar follow-up, we'll be recording this webinar, and that will go onto our website for prosperity, and you will get an email with the details of that and any other follow-up information that will help you get to those resources. As we go, we encourage you to ask questions, and we'll try and answer them as we go. I've got a couple of people with us today. Steve McCabe, who's one of our support engineers here at Safe Software, and Ryan Kaufman, who's with Spatial Business Systems. So they will be able to help us answer any questions that you throw in. So on your GoToWebinar panel there, you have a questions tab, and you can open that up and fire off questions, and we will try and answer them as we go. If we don't manage to get to them, or in some cases if you ask us something that's too tricky, we will follow up in an email with a response later on. So FME's technology capabilities are that primarily we're a data translator moving data between a wide range of spatial formats and non-spatial formats. At the moment we support 280 plus formats that Safe Software supports directly, and then we have partners such as Spatial Business Systems who developed secondary or additional plugins for FME, so that adds up. There's probably another 25 or 30 formats of those. And we support a wide range of data, spatial data in different spatial contexts, CAD, GIS, and over the years we've been adding raster, 3D and BIM information, and point cloud data. And so that has required us to add a wide range of transformation capabilities so that we can get the best out of your data as you move it between those different spatial contexts. So just as we start the webinar, and to make sure everybody's awake here this morning, Vancouver time anyway, it's probably afternoon for some of you. We've got a couple of poll questions we'd like to ask about your usage of FME. And so the first one is, how long have you been using FME? And if you can give us your answers on that one. Give you a couple of seconds there. Large number this time of users who have been using FME for more than 4 years, which is very interesting. Okay, so I'm going to close the poll now. And then here's the results of that. So we've got okay, so we had about 50% of us have been using FME for more than 4 years. Got about 20% of us not using FME, and another 20% using FME for less than a year. So that's kind of interesting. Okay, and then I've got a second poll here. I'd just like to run just so that we know where you are in terms of using FME. If you are an FME user, what version of FME you're using if you are an FME user. And it looks like we don't have anybody on the bleeding edge. So right now, our current release for FME is FME 2012. Majority of you are using FME 2012. Some still on 2011, but nobody has been exploring our FME 2013 beta releases, which that will be released as a full release in January next year. So hopefully some of you can upgrade to that release when the time comes. But we do encourage people to use our beta releases, and just remember, if you want to explore what is coming in FME, you can install more than one version of FME on the same machine, and they don't interfere with each other, so you can do that. Okay, thank you very much for that. Okay, I'm going to hand it over to Andy, who's going to continue the presentation and give us his demo. So this is where the technology comes in. Andy, I'm going to try and make you the presenter.
Great.
And
okay,
there you go.
See my screen?
Yep.
Okay, great. All right, so hello, welcome everybody, and thank you for coming along today. So I'll be going through and showing a series of mini demos that kind of focus on highlighting some of the specific, more complex issues of actually working with Smallworld data and exposing it through the FME SpatialBiz plugin. As I say, I have a number of little demos, so I'm going to go through and I'll show them in turn and give you some information. Halfway through, we'll stop and we'll do a couple more polls, but collect up your questions and we can figure out what we're doing. So the first demo I'm going to show you is actually just a basic reader demo. So I'm going to go off and generate a workspace. I'll be connecting to a local machine here, and I'm going to just wipe that out. I'm actually going to, when I connect here, I'm going to show external name usage for features. I know for a lot of European customers, there is a requirement there where the internal names of the Smallworld tables and databases and attribute values are different to the external names, and a lot of users need to use that external name representation. So in this first part, I'm just going to use external names only for the part of the demo. So I'm going to pull out gas mains and annotation. And I'll also pull out some valves as well. So having specified those, I'm going to store the results in an FFS data store. I mean, obviously you could store it to any supported format. I'm just using this format just because it's beneficial for me as part of the demonstration. So go off and build the workspace now. So when I look at the attributes, you can see the attributes are all in uppercase, basically the Smallworld external name representation. And rather than write to the actual output file, I'm going to redirect to the inspector just so that I can actually show you the results of running these more quickly, because we've got quite a few things to go through. So having selected that, go off, it will then go and search through my local database. I think there's about 12 to 15,000 records or something in this data set, so it'll take a few seconds to run. So what it's doing is it's pulling out those gas features, saving them as FFS file records, and then it will open up the inspector so we can see the results. Okay, so there's all my results come back. I've got mains and valves. I'll just change the color on that. So let me just zoom into an area and I'll just show you some of the results that came out. A gas main, the attribute associated with it. I just want to draw your attention to this FME DB operation, which is an attribute value that's added to the data set by FME as the product runs. I just want to, I'll be coming back to that later on, but this is just basically to show that information. A whole series of other information comes out as well. If I select valves, I can see the attribution associated with that. What's also interesting is on the annotations here, you'll see there's 2 dots, so hopefully you can make out that there's 2 dots there that are being displayed. The Smallworld system, the SpatialBiz plugin, by default will generate complex geometries. So if I look in the geometry box down here, I see I have a geometry type of multiple geometry, which actually means that indicates that it's containing 2 geometries. There's the annotation large geometry, which is one Smallworld geometry, and then there's the annotation small geometry, which is another Smallworld geometry. And that's how we handle complex geometry representations in Smallworld. As we bring them across into the FME world, we actually generate these complex multiple geometry representations. FME has a very comprehensive vector and raster geometry format, but there are some additional attributes that are relevant to Smallworld, which we can't necessarily store within the FME model. So these are then stored as geometry traits. So things like the justification for a text string. This is the Smallworld justification. Alignment is a more human-readable bottom left, center, top right, etc. representation. Obviously, world and universe ID, to those who are familiar with the internals of Smallworld, any geometry can exist within a world, so we tag those so that we know that information is there. So that's basically just a very quick overview. I'm going to go back now to the source data that I was pulling out and actually put some filters in place on it. So I can select the feature, go to the format parameters, and I can specify a predicate. So in this instance, I'm actually on my gas main. I go to my export predicate, and I can say I only want to pull out them if the material is equal to cast iron. Okay, so now hopefully next time that runs, that will only pull out cast iron pipes. On the main annotations, I want to control those, and I actually want to dictate to those that they will only pull out if the associated gas main has been exported. So we're basically navigating through the join. To do that, I use this export when joined exported option, and I specify that it will pull out main annotation when any main as associated is also pulled out. Okay, that's not the whole picture though, because basically the way that this works is it'll pull out the mains, and then it will pull out the main annotations, but the mains would have had to have run first in order for it to know that a main was extracted. So I need to be able to control the order. So all of our plugins, the SpatialBiz for Smallworld and the Oracle Spatial one for Oracle Spatial, include a definable character called export order. Now what that allows me, and it's just a numeric value, and it just means when you export, it will export in low to high order. If you put no value, it just means 0, so they're all the same. So if I just put 1 here, I know that the main is at 0 or default, so it means that I can guarantee now that the mains will always come out first, and then main annotations will always come out second. So now when I run it, it'll go back, it'll find gas mains, it'll filter them by being cast iron, and it will then only pull out the main annotations that are then associated with that. Again, it will take the results and it will write them to my file over here. I put no such filter on the valves, which are the pink ones, so we're not seeing anything kind of controlling those. So, I'll come down here. Unfortunately, these dots are very, very small, but if I select one here, we should be able to see that The material is cast iron. If I select an annotation over here, all we know is that the annotation is just associated with one of the domains that was pulled out. So we can put that kind of dependence in there as well. Now finally, I just want to go back and just very quickly make a few changes into the kind of information that we're pulling out from the workspace level as well. We have a series of parameters. We can specify max and min bounds. We can specify the alternative where you want to get the data from, a checkpoint. So in this case, we could potentially say, I want to only extract data that's related to a circuit or a cathodic section or some kind of pipeline system reference or whatever. I can specify information about whether I'm synchronizing. I can specify the world I want to pull the data from. I'm going to change this export topology flag though to say yes, and I will just go ahead and run that again. So what will happen now is it will actually pull out the nodes and links from the Smallworld, and it will append them to the features as geometry traits that can then be used to build network models in target systems. So, and I'll be showing that a little bit more detail, but I just want to go in here and actually just show you really quickly what it looks like. So here's my main. If I look at the geometries of the main, you'll see that we have links associated with the route geometry. So the nodes and the links are all tied in there and are made available. If I then go and look at the valve, I will see on the point geometry that I have the nodes associated with that. So the node ID is the Smallworld node ID. We can rebuild a fully functional network topology by going this way. Okay, so that's the end of that first kind of demo. Basically, I wanted to show you just the ability to actually read data out and process it, etc. So now I'm going to go on and show you a different kind of demonstration. This is actually going to be looking at a different way of reading data up front. So I'm just going to close this one out, and I will open up I think this is the one I want, yeah. Okay, so this is using the SpatialBiz plugin, but not as a reader, but as a feature reader. Okay, so FME have a really nice little transformer called a feature reader, which allows you to dynamically read from a data source that you specify on the fly, and it receives then input from other readers. So in this case, all I have is a creator, which is building a bounding box, which has a specific max and min tolerance associated with it. This could be a shape file that has a series of areas, or some kind of Oracle Spatial database that has a polygons or some kind of other geometric or geographic representations that is then going to be fed in as input into my feature reader. When I look at the feature reader, I can see that I'm looking at this database locally. I'm pulling out poles and primary conductors in this case. Scroll back over. I now see that I have a where clause defined. If I click on the where clause, what I've said is, for the poles and the primary conductors, I want to pull out poles where the height is equal to 40 and the primary conductor where the status is equal to existing. We can put in multiple compound predicates here to support retrieval of data. And then finally, I want to say, select only the features that intersect with the initiator's feature bounding box. So I'm saying, only pull out the objects that lie within the bounds of this created object or that thing that's there. So basically, this gives me the ability to control a lot of information about how I actually run the extract, above and beyond if I was actually reading it as a straightforward reader type class object. So go ahead and run that now. This will actually write out to the inspector as well, so I can see the results coming out. Okay, so a small subset of data is pulled out there. If I zoom in, and hopefully you can still see some of these grey objects here, but so what I have is poles where the pole height is equal to 40. I think there's significantly more poles in this database, but this is just limiting all to those. And then conductors where I think the status was existing was the predicate that I had in there. So that's basically using a feature reader, which is a really powerful transformer that really leverages and extends your writer capability. Okay, so now I'm going to go to a poll. Mark, can we put the poll back on now at this point?
Yeah, we can. So we're going to go and ask, just to make sure everybody's with us still, which version of Smallworld people are using. So I'm going to launch that poll there, just to find out where people are in their Smallworld usage.
So do I have to make you the presenter there, Mark?
No, I think that's done. The poll's up there. It's okay.
Okay.
And nobody in the group has updated. I'm going to close that poll now. Nobody in that group has upgraded to Smallworld 4.3, which is interesting. Andy and I were just recently at the Smallworld user conference. There were quite a few people who had upgraded to 4.3, but in our group here, the majority are still sitting at 4 dot something or 4.2.
Yeah. So just to kind of add to that, then the SpatialBiz plugin supports all versions of Smallworld through 3.1 SP2. We've tried very hard to maintain support all the way through. I'm not sure if there are any 3.1 SP2 customers out there still, but
yeah, and we're just going to have a second poll here, looking at which are in the group. We've got about 40 people in the webinar today. Which of the varieties of Smallworld read and write people are using, whether it's the SpatialBiz one, the sort of default one from the GE Smallworld, or some of the older ones. And somebody did say here through the questions that they are upgrading to, in the process of upgrading to Smallworld 4.3. Okay, and so I'll just share. I'm just going to close that poll and share it with everybody. So the majority of people are using one of the older GE Smallworld translators. A few people have upgraded to 4.22, and we've got about 20% people using the SpatialBiz plugin. So that's great. Okay, I'm going to hide that, and back to you, Andy.
okay. Thank you very much. So everyone can see my screen again now.
Yep.
Okay, so having done a couple of reader functions, I actually just realized I missed something as well that we can go back to as well. Basically, the ability within the SpatialBiz plugin to augment Smallworld features with derived physical fields and geometry. So when I click over here, you can see the physical attributes associated with the object. This one hasn't been set up with anything, but basically we can add additional attributes in here that are either physical, relational, spatial, information. So we could add in information like the style that the pole is drawn or the conductor is drawn, the color of the conductor. We could ask to add to the exported attributes things like the structures or the equipment which is attached at either end of the conductor. Even if it wasn't represented as an attribute within the Smallworld model, we can augment that model on the fly within the configuration of the SpatialBiz plugin. So that's something that's very relevant and worth bearing in mind. We do it on a lot of the projects we work on to actually augment the model. So now I'm going to go on to a writer demo. So I'm going to go into a transformer import. So this is basically taken as read that we could write data into Smallworld. I just want to target possibly one of the most complex aspects of writing data into Smallworld, and that's that it actually has its own unique value allocators. So I will have source data that has as a unique key on a parent and a child. In this case, I have a transformer, and I have a transformer unit. On the transformer unit, I then have a key, which is the transformer ID, which is a foreign key to the transformer parent. Okay, the source data in this case is all valid in that the transformer ID is valid, the transformer unit ID is valid, and the foreign key is correctly linked to the transformer. But when we load the data into Smallworld, everyone will appreciate that unique value allocators in Smallworld will automatically generate new ID values for the transformers and the transformer units. So the example I'm going to show here is how we can set up the SpatialBiz plugin with a little help from this transformer in the middle called a feature blocker to allow it to read in data, allow key generators to run correctly, and then automatically update foreign key values to ensure that relationships are persisted. Okay, so basically one of the key aspects of writing data into Smallworld where we want to maintain that relationship is to actually order the data correctly. Now, the FFS data source does not necessarily have a way of controlling order, or there is not a way of actually saying this one has to go before this one. You can order them within the workspace, but sometimes it's kind of hard to make sure you've got that right. So we have a little transformer that's been built called a feature blocker, which means the parent object, the blocker object, the transformer, they will be fed into this blocker and they will block all transformer units until they've finished running. So basically the transformers come in, they run out, they go into the database. When they're done, regardless of whatever order the data came in here, the transformer units will then be allowed to go through and they will be allowed to pass through. And so that's one of the main cruxes. We need to get the data to load in order. The second part of it is this ability to go and search for the old key value and replace it with whatever is the new key value that was generated when the feature was inserted. So we have this concept of a record finder, which is a macro. Within the SpatialBiz plugin, macros are basically procedures that are run within Smallworld. They're prefixed with the @ sign. So this just means when you are, and we'll just open it up so you can see it, the record finder macro, what it will do is it will find an electric transformer where the ID is equal to the transformer ID that was fed in from the source object, and it will find that record, its old version of the record, in the caching system that's used as records are loaded, and it will then replace the representation of the transformer as a foreign key object with the new transformer that was generated. So the record finder, when it runs, will hunt within the database in Smallworld and say, this is the object that you created that used to be called this is what it's now called, and I will offer up this new value into the foreign key and set it up so that it will automatically run. So now when I run this, I'm going to read, and there's only a couple of objects here. So there's two transformers, two transformer units. They go over here, they go into there. So I'm now just going to open up this database so you can see what it looks like. This is the geographic representation of the area here. It's actually around this area here that were the transformers that I set up to do this work against. And I'm now just going to roll forward. My database, and we should see the transformers pop up now at this point. So there's the transformers that have now come in. They were loaded into this FME alternative. So now when I select one, you'll see the attributes are there, and the transformer units are automatically populated. I click on the transformer units, and it shows me the transformer unit object that was pulled in and saved there. And the same goes for this one up here. So that's basically, it's a bit hard to kind of demonstrate that kind of complexity, but that's probably one of the most complex aspects of actually writing data into Smallworld, and the area that I wish to focus on. Okay, so the next demo I'm going to go on to is an FME Server Demo. So let me just go and close this. So I'm going to connect up to my FME Server instance. It's sort of called there, that's fine. Okay, so there's my my FME Server instance. I have this FME Server 2.fmw file. I just want to download that just so I can show you what it looks like. Okay, this is a very simplistic workspace again, just to show over the concept. So we're reading from Smallworld. We're reading, in this case, min-roads, parks, and hotels from a Cambridge demonstration data set. We're breaking the geometries up because we have complex geometries. We're breaking them into individual geometry components, and then we're going to write them into a generic writer. So if over here, you can see the generic writer has the ability to actually define the output format on the fly. So I can specify, in this case, the default is AutoCAD. I can specify shape or whatever else I want. So I can just go through and actually see that information directly and just specify how I want to send the information out. I can also specify the input min-x, min-y, max-x, max-y coordinates extents that I want to read the data from. So I'm just going to go into my FME Server environment, and I'll show you there's my FME Server 2 workspace file. If I log in on the user side, go into the data download, SBS, FME Server 2. I'm just going to click and run that one, just let it run. So this is going to put no spatial bounds on. It'll go off, submit the job, and it will read it, and it will store it as an AutoCAD file. So if I open that up, get rid of that, get rid of that. So now if I open up, there's my file there. If I open up AutoCAD and just drag and drop that file into there. Where's it gone? Okay, so obviously decided it was going to do. So there's my AutoCAD export file, information on the layers, etc., as the data is pulled out. So that's just using the data download service within FME Server to process the data, which is kind of nice, you know, in terms of working. I also now want to show a different environment, and this is based on a demonstration set that SAFE actually offer with the FME Server. And in this case, I have a little Google demo, obligatory Google demo. So this is my predefined Google boundary, which is looking at the Cambridge database in the UK. I have the ability to zoom in, pan around. And then once I've panned around where I want to be, I can then say, okay, here's my area. There's my area of interest. Select the objects I want to download. I'm going to pull them all down. In this case, I'll store them in shapefile, go off and submit that request. For demonstration purposes, it shows me what the request is. Goes off and runs. There's my result. Come back. Open that up. And I will save that into, excuse me, I'll save that into a directory. Now if I open up ArcMap, and I just select the shape files. Okay, so there's the data that was pulled in. So basically, there's, you know, exporting features, storing them into shapefile format. Here's the attributes associated with them. So it's all there. So basically, that's just kind of showing that capability of using FME Server with a GUI, with a Google Maps GUI to actually integrate and read data out. So the next part of the demo, how am I doing on time? I think I'm okay at the moment still. The next part of the demo now is to look at a synchronization demonstration. So this is, so basically what we've been looking at so far is excuse me. What we've been looking at so far is just reading and writing data from Smallworld using the SpatialBiz plugin. SBS also market an Oracle Spatial plugin that has some very specific capabilities built into it to support synchronization of data with Smallworld. So in this case, I'm just showing one side of the equation, the SpatialBiz reading and writing into Oracle Spatial. So I'll highlight some of the attributes associated with the SpatialBiz side. So we've got some hotels, roads, and parks that are going to be synchronized with Oracle. My connection information associated. I can specify the alternative, which is my synchronization alternative here, the sync demo. I have a checkpoint of sync, and I am synchronizing is set to yes. What that means is every time I press the button, it will go off and it will find no changes, because it's basically looking to see if changes have occurred since the last time it ran. If I run it again, it should find no changes again. I can specify other information in here as well, but basically coming down to the Oracle Spatial side, this tells me that the JDBC connection it's going to use, the spatial reference system. This is British National Grid for storing the data in. So working with the SpatialBiz plugin, it's taken any of the source data from the Smallworld database, which is in a millimeter coordinate, a millimeter unit system, and it's projecting it automatically on the fly into a standard EPSG SRID reference system. So it's in either in a feet or meters coordinate system that can be then used by Oracle Spatial directly, by FME, by any other GIS type tool. So in our case here, we're using British National Grid meters. So here's the 27700, which is that SRID for that. We can also define a series of procedures, start and end procedures, post-transaction procedures, which are very useful for recording additional information like the history of the changes that have occurred. We've recently done an example where we do the types of changes down to the actual attribute level. We can actually record the fact that on this synchronization run that occurred on this day, this attribute of this object was changed from this to that. We can go down to a very, very detailed level of metadata that can be used to track and trace how changes are occurring within your Oracle Spatial database. In addition, we are using a network, an Oracle Spatial network, so we're using the Oracle Spatial network model to store the network information, and I'll show that in just a minute as we kind of go through and we run some processes. So what I'm going to do now is actually go into my Smallworld system. Okay, so here's my GIS view onto this Oracle Spatial data, onto this Smallworld database, sorry. So click on versions, just make sure I'm in the right demo. I'm in the sync demo alternative, which is what I'm showing. Okay, so if I go ahead and I select an object, I'll select this playing field here, and I am going to clear the trail, and I'm going to create a new representation of it. So update the geometry. I'll also select this annotation here and change that from Cambridge City to Cambridge Town. So that's a physical attribute change and a spatial attribute change on the same table, but I mean basically it'll work on the others as well. So go off and save those changes. So normally, obviously, I wouldn't work in the actual sync demo alternative. I'm doing it for just for demonstration purposes here. Typically, you'd work within your design alternatives or your other engineering alternatives. And as the data merges and posts around the Smallworld version management hierarchy, at some point it will get into the synchronizing alternative, at which point it will then be eligible to be sent over to Smallworld. So here it is. It's now in sync demo, ready to go. So if I go back to my workspace over here, I can now press the synchronization button, and it will go and it will check and see what has changed in the source database, pull out those features, and in this case there's only 2 parts that changed, and it's written the data over into Oracle Spatial. So I actually have, from a visualization perspective, and that's obviously the hardest part of a lot of the things we do, I use SQL Developer a lot to just show that capability, and I've zoomed into the area already. It's all ready to go now. All I have to do is refresh, and we should see the playing field boundary here change, and the name of this label should change as well. We're using just a spatial reference 27700. I have other ones available for other projects I'm working on as well. But basically, you see that the boundary changed and the name changed to Cambridge Town at that point. So that information has now been sent over, and the changes have been made. They're represented within the Oracle Spatial environment. On top of the spatial changes and the physical representations that you see here, I also want to show you some of the topology tables as well, just for representation, just so you know what's going on. So it's within this database here. If I scroll down to the road network, this the roads and the hotels here all form a network path on the actual road network. So I have the road links here. If I look at the data, I can see the link IDs, and these are the link IDs that came from Smallworld, start node, end node, plus the geometry associated with it. If I scroll across, I can see additional information like the cost, which is in this case is the length of the road in the local coordinate system, I believe, and then things like the feature ID and the road type, just additional metadata or attribute information that we want to pull out to help the representation. In addition, we also have the nodes as well, so we can see the individual nodes and their representation if they're associated with a point feature in this case. And then finally, the Oracle Spatial plugin will also build this reference table here. And so this is an extension to the Oracle Network model that allows us to indicate that Smallworld features, or Oracle features rather, are associated with topological elements, links and nodes, and potentially polygons as well, within the manifold network. So having this kind of reference table there that allows us to say these features are associated with these links and these nodes means that we can use the Oracle Spatial network modeling tracing operations, which are very comprehensive, and then we can use constraints, which is a standard extension to that network modeling environment, to leverage and access attribute information from the associated road, in this case, or main, or primary conductor, or switches, or valves, etc., to determine whether or not a trace is actually open, the path is open, whether the road can be navigated because it's in the right direction, whether the primary conductor is part of the same circuit that you wish to trace, to identify. So basically we can actually, because of this reference table, we can link across, and we have a number of very comprehensive examples of actually how to do that. So that's, that's kind of writing, using the spatial SW sync and how we can bring data across. As I said, that we would have an equivalent database, or equivalent workspace rather, that would bring the data back from Oracle Spatial to the other direction. When we're pulling data from Oracle and reading it into Smallworld, we would either use the network Oracle Workspace Manager, to determine change on the Oracle side, or we could use triggers, which is a very commonly used approach to determine that change has occurred within the Oracle Spatial tables. Okay, now finally, I've got one more demo to do, which is the Esri integration demo. So I don't actually need to use Workspace at all, the FME Workbench at all now for this. So I'm just going to go into Arc Catalog. Okay, so Arc Catalog has been basically the SpatialBiz plugin has been installed into the Arc Catalog environment, or the ArcGIS environment, through the through the FME extension for ArcGIS. So this tool here, once FME is extended into ArcGIS, allows you to define FME connections, which then give you additional behavior for reading and writing data from FME supported data formats directly with the Esri tools. So we've extended for ArcGIS. Having done that now, I can go in and I can say, okay, create an FME connection. And I'll be using the SPS plugin for Esri extension. This is a slightly different configuration of the SpatialBiz plugin, which allows it to basically support simple feature representations and has some more information associated with handling topologies and stuff. But basically, once we've done that, I go in, specify what are the objects I want to go and get. So let's say road, park, I can also specify the bound types. Now we've defined some here, but we can add more in. It's relatively straightforward to add additional retrieval bound criteria. We have a minimum bounding rectangle, which can be defined either by max and min, by min plus width and height, or we can define a table predicate, which is basically saying search in the Smallworld database for these types of features that meet this criteria, and the bounds will be restricted by the extent or the geographic representation of those features. In this case, I'm just going to go straight for all the data. I've set the coordinate system to the British National Grid just so that Esri understands it up front. Go ahead and run that. So now I have this connection which has been defined in our catalog, which allows me to go and have a look at some of the data. So when I click on one of the features, it will go off and it will populate to show me the features that it read. So there's my part coverages. If I click on here and I say refresh, some of these feature classes didn't actually contain any data. So the refresh operation just filters those out. So now when I look at these all contain some nice data for me. So I've defined now this connection. So this allows me to view them as individual features, but instead now I'm going to go into ArcGIS directly, or ArcMap rather directly, and having opened up the tool, I will then go off and connect to my FME connection data source and add in some data. So if I click on Add, so I get my typical list of all the things here, plus my FME connection here, click on that, and I will see all the attributes associated with those, all the connected classes that are available there. Accept those, and now I have my representations pulled out from Smallworld that allow me, in this case in a read-only mode, to interact with the Smallworld features. And this, basically you can have a server set up in the background. ArcGIS clients can just go in and define their own connection, saying I want this based on these criteria, pull the data in, and then having done that, they can then define their own thematic maps. So symbology on categories, specify class. So we'll color code the part coverages based on the class. I will color code also the road center lines based on the road type in this case. So there's a series of criteria I can apply. So really and truthfully, it just gives me the ability to interact with the Smallworld data directly in a read-only fashion. If I want to write to the data and update it, I will have to take the data and export it to a personal geodatabase or shapefiles. I can then edit those, or file-based geodatabase. I can then edit those as a separate data set and then send them back to Smallworld through the FME engines as a standard set of transactions that are going to be sent back. Okay, and that's kind of about the stretch of the demo. I guess I did actually miss a couple of things early on in some of the earlier parts, but that's really all I was going to mainly cover. At this point, Mark, can we go back to the slides and we can talk about some of the additional benefits?
Yeah, absolutely. Let me see how I do that. So I've got the slides here. So
do I make you presenter?
Yep. Yeah, if you make me the presenter, then I can pop up the slides.
Okie dokie.
And there we go. Okay.
Okay, so yeah, so we wanted just to reiterate a couple of things. I mean, one being the synchronization engines. We put a lot of work into actually getting this thing to work very smoothly in terms of reading data and synchronizing it between Smallworld and Oracle. We're using standard off-the-shelf products to actually support that. We're able to, because we're going through the FME environment and the workbench and the associated transformers, as Mark said, over 400 transformers, we can basically rip the data, slice and dice it, merge, do all sorts of things to it to actually mirror data from one Smallworld schema into a relatively different Oracle schema. We have a lot of capabilities there for synchronizing that across and actually handling multiple combinations. We can merge in other data sources, so you could connect to a CIS database on the fly to connect in additional information, a distribution management database, analysis information could be brought to bear in terms of how you blend features together to actually generate your synchronized Oracle schema. So a very, very flexible environment. Also as well, using the SpatialBiz and the Spatial, which is our Oracle Spatial plugin, allows us to automatically handle this network model population, which is a extremely important aspect of utility, Oracle database creation. The ability to actually support tracing still, and we can do all sorts of things with the tracing, jumping across networks. That relationship across the feature layer to the topology layer really helps with associations that need to be done. We can handle internal worlds. I mean, I guess an example that I haven't actually got here to show, but we can either bring data across as internal worlds and keep them in separate columns, because basically when you write data into Oracle Spatial, you want to keep the same spatial reference ID for any specific geometry column, but you can have multiple geometry columns in the Oracle Spatial table. Another approach that we've used is to actually take the internal world data from the Smallworld side and explode it and reproject it on the fly into the main GIS world coordinate system. We then store the data within the Oracle Spatial environment in that projected form and are able to then pull it back and actually store it into its internal world representation afterwards. So we store not only the geometry information, but a lot of metadata like the world information, style information, etc. can all be put together into the Oracle Spatial database to support its operation and its needs. And obviously it goes without saying it's high performance and cost effective. So we got another slide. Okay. Okay. Is this for you, Mark?
No, you carry on. Okay,
so I mean, really, truthfully, the SpatialBiz plugin and the Oracle Spatial plugin as well that we've shown kind of indirectly have a lot of very powerful features. We've been writing these for a number of years now. They've been refined, revised, extended, very comprehensive read-write capabilities, support for FME Server with no configuration really required whatsoever. Basically, you just drag and drop the DLLs and the FME install into the FME Server directories, and it will then start working with you. Support for Oracle and Oracle Spatial synchronization, and then also we've extended it to support the FME extension or interop extension for Esri, so that we can then, using Esri clients, we can directly access Smallworld data.
And of course, if you need further information, you can contact the SBS folks if you want more information about their plugins that they have built for FME. Very comprehensive stuff, indeed, impressive. We've got a couple of questions about training to see what the interest might be in advancing your skills with some of the FME tools. So if you're interested in FME training, perhaps you can just quickly let us know, and we can work with SBS to organize a training session if there's enough demand there. Okay, I'm going to close that. And then, as always, at an FME webinar, we give away FME desktop training, so that's not around the Smallworld or SpatialBiz plugin, but just the introductory FME desktop training. So if you'd like to put your name in for a free seat at the FME desktop training, let us know, and we'll put you in the draw and see if we can get you some seats to that. Okay. So we'll just close that one as well. Oh, there we go. So we've had a few of you asking some interesting questions, some of them very specific, so not so applicable to the whole group, but I've got a couple here that I thought would put Andy on the spot and see if he can answer. So one question from your Esri integration there, Andy, is have you ever experimented with integrating your plugin with ArcServer and serving up your Smallworld data through ArcServer to ArcServer services like a map or REST services?
I personally have not done that, no, so I don't know. I know we had one of our guys back in Denver was looking at something like that, but I'm not sure what the output of that was. I mean, I kind of throw the question back on FME. Does your Esri extension, will it support SDE, integrating with other?
Yeah, FME it does. So, yeah, in theory, there is no reason why that should not be done. FME can be used to extend the format reach of ArcGIS Server. Obviously, ArcGIS Server is totally tuned to being able to read the Esri formats and some other formats. But if you need to extend the format reach, FME can be used at the back end of ArcServer to do that. So I don't see any reason why you wouldn't be able to do that with the SpatialBiz plugin there. And then one other question there that came up was a question that kind of asked, you know, which of the functionality that you've been demoing today is kind of unique to SBS, or what would people who are using the sort of existing or the sort of the default GE Smallworld read and write are using. So maybe you could give us a two of the three of the what you think of the key differences between the SBS plugin and the GE Smallworld reader and writer, Andy.
Yeah, that's an interesting one. So I mean, I've worked with the GE one on and off over the years. I'd have to kind of look through some of the capabilities. So I think, I mean, I'm not 100% sure exactly what the latest version of the GE plugin handles, but I do know that we do a lot of the geometry processing for arcs internally within the C++ libraries. So, you know, we don't have to grind arcs into straight lines. And I believe last I understood that was not the case with the Smallworld plugin. I may be wrong, but you know, we can basically handle the arc splines, elliptical curves, whatever. We can handle it all and pass it all out into FME world as part of the FME geometry, and then let FME handle what it wants to do with those geometries. I'm not sure if topology can be exported with the GE version.
I think
yeah, I mean,
dealing with more sophisticated table joins and predicates and things, I think that seems to be an area that you've done quite a lot of work on.
Yeah, I mean, I would certainly think that ours would have the capabilities to support a lot of very comprehensive capability and requirements. So, you know, if the person who has the question would like to get in touch with me directly and ask me specifically on things, or if it knows that, then I'd be certainly happy to respond. It's hard for me to say, you know, this is the max or the best difference between it. You know, we just support lots of capabilities. Ordering the features it may not seem like very much unless you actually have to go through those processes of updating or reading data such that you can ensure these kinds of feature classes get loaded into Smallworld or are read from Smallworld before these other ones. But if you can't solve that problem, it's an extremely difficult thing to overcome.
Yeah. Okay, I think that was. Oh yeah, here we've got one question there that we might as well throw out there. Is your synchronization with Oracle, is that a two-way sync? You demoed going out from Small to Oracle. Can you come back the other way?
Absolutely, yeah. So basically, you define a separate workspace that would be reading from Oracle Spatial, and it would be determining change based on either using Workspace Manager, which is Oracle's version management approach, or you could use triggers to actually identify the changes, and that information as it comes out would then be written into a Smallworld alternative, and it will be merged and posted within the environment as well. Actually, one thing to add as well we've just recently implemented, which is a really powerful capability. As we're reading changes from within Smallworld, typically the default change detection using the ds-pling version attribute on the feature is only updated if you actually change a physical attribute or a spatial attribute or some substructure component of those features. We just recently modified our detection system on the Smallworld side so that we can detect changes that occur in the Smallworld data if it's from a derived field. So we have a number of customers who are doing this where they have derived fields which are like the circuit identifier or the CP structure, and then when you potentially do switching or valves opening and closing, that can change a derived field value, which doesn't actually change the attributes, it's just how it's represented when you look at the data in Smallworld. But we can now actually put hook points in place where we can say, okay, and this is another way of defining change or understanding change in the data, so we can search for those changes where derived fields have actually changed and actually read that information out at that point. So that, again, is kind of a maybe hard to clarify or quantify, but it's actually a really important thing because there are a number of Smallworld sites that have quite involved information which is only available through derived fields. And if you're just doing change detection, pure change detection within VNDS, you would not get that information being identified.
Okay, that's. I think that's probably most of the questions that might apply to the whole group. So that kind of wraps up our webinar, and amazingly, we are under time. So normally we run under time. So Andy, I know I lit a fire under you earlier in the week to say we had to stay within the hour, and you have. So that's fantastic. Thanks a lot.
I have a lunch appointment.
Here are the contact details if you want to follow up with either Safe Software, info@safe.com, or info@spatialbiz.com if you want any more information. Thank you very much to the Spatial Biz folks for putting together this webinar with us. There's a lot of information there. They do have some additional resources on YouTube, so search for Spatial Biz things on YouTube if you want to have a look at the movie. We will be following up with an email to everyone who's attended the webinar today, and if you want a free training seat, that will have that information in there, and also there will be the links to the recording of this webinar if you want to share it with colleagues, and also the PowerPoints themselves will be posted up, and there'll be a link to that. So I think that is it for today. So thank you very much. Thank you, Andy.
My pleasure. Thank you, everybody, for attending.
And we hope to see you at one of our future webinars down the road. Thanks a lot, and good day, and have a good weekend when it comes. Bye.
Bye.